Welcome back to another video. In the previous video, we covered the two-phase mixture formula, which was given by these. So, in case you didn't watch that video, you need to go back and watch that video, and you look at how this formula is derived. And in this video specifically, we're going to look at the interpretation of the formula, what it means, and what it stands for. This is going to be quite a short video, and it's part of a bigger playlist that we've created about thermodynamics. So, in case you have a friend who is doing thermodynamics, you can share the video with them, and it'll be quite of help. Right? There's a lot of source on YouTube, but this specifically is breaking down some of the concepts in thermodynamics. So these could be another helpful material that your friend or yourself could need for your education, for your thermodynamics. So let's get to it straight. And the formula is given by lowercase v is equal to 1 minus the quality concept multiplied by lowercase v subscript f plus quality concept multiplied by v subscript g. So what does this mean? Remember, in a previous video, we assumed the tank or an electric kettle of a rigid volume. Electric kettle, when you're using an electric kettle, you buy it from a supermarket. You're never going to change its volume. If it contains 1 liter of water, it will always contain 1 liter of water. You can choose to put 1 liter of water or less. So its volume does not change. It's rigid. But whatever you're going to put into that electric kettle, let's say water in this case, its volume will change when you start boiling. Okay, when you're over boiling, for instance, water, once it hits 100 degrees Celsius and it starts boiling, evaporation is going to start taking place, and some of the water or some of the liquid is going to transition from a liquid phase to vapor phase, and that change will affect the mass of the liquid of what you initially put in the electric kettle, and now you're going to have a different mass which is going to evaporate, and that's the vapor phase. So having that at the back of our minds, once you're dealing with calculations in thermodynamics, and you calculate and you find that the quality concept is equal to 0. Once you do the solving here, you're going to 1 minus 0 is 1, 1 multiplied by lowercase v subscript f. You're going to remain with this here, and because of this 0, this is going to cancel out. So that means your specific volume is equal to the specific volume due to the liquid phase. What does that mean? That means uh, the mixture is entirely liquid. Maybe that that system, the electric kettle of yours and your water, they haven't boiled to the vapor phase. They're all still liquid, and we could say that there's no mass that has been taken out since it's still exactly how you put it. Now, should you do a calculation and you find that your x is equal to 1, you're going to multiply 1 here and you get v subscript g, and 1 minus 1 is 0. This will remove the concept of the liquid. That means the whole mixture is entirely vapor. What does that tell you? Maybe you've overboiled your water and the liquid is just phased out and it's now vapor. That's what it means. Now, should you get something that is in between 0 and 1, maybe 0.5, maybe 0.59, maybe 0. Anything between there, the mixture is weighted between the liquid and vapor, and I think this is the most real and the most applicable because it's quite not normal to find uh, that you've put water in an electric kettle and you find it's totally become vapor. No, you will always find that there's water and vapor, and that can be given by this formula here. 0 is less than or equal to x, uh, less than or equal to 1. So the quality concept will always lie in between here. So in case you do a calculation and you get your quality concept somewhere like 5 or 9, just know you are messing up an entire calculation. And I already said that this video is intended to be quite short, and that's all. That's the interpretation of a two-phase mixture formula, and this is the formula. So in the next video, we're going to look at specific enthalpy for a two-phase mixture. So check out the video. The videos are quite short, they don't take a lot of time, and yeah, improve your grades. And see you in the next video, and check out our playlist and comment and share with a friend. Thanks for watching.